All right, so I think I'm recording here. Let's take a look at this problem. We have two functions f and g, and we want to determine if these two functions are inverses of each other, and to do that by function composition. So we want to find f composed with g, and then g composed with f. So let's start out, and I'll find f composed with g of x, which can be written as f of g of x. So g is the function, the square root of x minus 3. F is the function that is a quadratic function. We'll always have three terms. The first term squares the input. The second term adds 6 times the input. And the third term just always adds 9. We're giving it this radical, this binomial, square root of x minus 3. So be careful here that exponents don't distribute. Maybe it would be best if we multiplied this in the form of a table, because people may just not have enough experience to do it in their head when you're multiplying these radicals. So we get and I guess I should make a comment that I know that the absolute values here are not needed, because I know that the square root of x, I wouldn't be able to take the square root of a negative number, so I know that x has to be greater than or equal to 0, so absolute values are not needed on that. So now we can combine like terms. We have these terms that cancel each other. And 9 plus 9 is 18, and that cancels with that minus 18. So we do just get x. But we're not ready yet to say that these two functions are inverses of each other until we calculate the function composition the other way. So let's find g composed with f. So f of x is this quadratic function, x squared plus 6x plus 9. That's going to be the input for g. Well, what does g always do to the input? It always takes the square root of the input and then subtracts 3. So if we factor x squared plus 6x plus 9, we'll see that it's a perfect square. Now I have to be careful here, because I definitely am taking the square root of 0 or a positive value because this is being squared. That doesn't tell me anything about x itself. So, I have to make sure that x plus 3 is a positive expression. So I need absolute values around this x plus 3. Now, if I have further information about x, maybe I can simplify this. So really, I think the only way to justify of whether or not what we can do with this expression, absolute value of x plus 3, is to look at the domain of this function, look at the possible x value. So let's find the domain of this function composition. So when finding the domain of a composition, we start with that second function f. So what is the domain of f? Well, since f is a quadratic function, the domain of f is all real numbers. There's no variable in a denominator. There's no square roots. For g, the square root of x, well, that has to be positive. So it's pretty easy to see that the domain of g is 0 to infinity. So we have to make sure that the output of f is always is positive. So I need to make sure that f of x is always greater than or equal to 0 to be in the domain of g. Well, what is f of x? It's this quadratic. And I know that I can factor this quadratic to x plus 3 quantity squared. And I know that the critical point of this is negative 3. So it only has one critical point at negative 3. This parabola that opens upward comes down and touches the x-axis here at negative 3. This entire parabola has y-coordinates that are either 0 or infinity, and that's happening over the set of all real numbers. So this doesn't add any restrictions to the domain of f, which was already all real numbers. So the domain of this function composition, g composed with f, is all real numbers. So it was good that I did put these absolute value symbols around there, because it's possible that x could be, some number like a negative 4, and negative 4 plus 3 is a negative 1. Well, see, the output of a principal square root is always 0 or positive. So since this doesn't simplify to x, even though we have the plus 3 and minus 3, it doesn't simplify to x. These are not inverses of each other. Now, that was all looking at the function composition. If we go back and consider the graph, x squared plus 6x plus 9 is a graph that opens upward. And it fails a horizontal line test. It's a function, but it's not a one-to-one function. So it's no surprise that that these two, that it doesn't have an inverse. So if it doesn't have an inverse, then there's no way that g could be an inverse, because f doesn't have one. So our final answer is that these are not inverses, and that makes sense if we consider the graph. Hope that helps, and I'll talk to you later. Bye.